This joke was really good when I was practicing it in the shower this morning. It's going to bomb now. I'm just going to keep on rolling. My name is Kyle Forster. Before, so I'm at RunWhen. Before RunWhen, I was at Google. I'll talk about that. I'll talk about that in a minute. And before that, I was the founder of a company called Big Switch Networks. I think to Steve's earlier question, we used SDN to build ultra high reliability data center networks out of white box switching hardware. And so that's kind of how I got into reliability. And this was like 15 years ago. And we got there because our first customer, he looks me in the eye, is Kyle. If our network goes down, there goes capitalism. I think I was serious. So, it's been a ride. To pay for my sins, I sheltered in place during COVID at Google. I loved it. I was on the PM team for Kubernetes. You all can read faster than I can talk. So let me just summarize the slide saying 2 out of 3 ain't bad. I like to think that we are going to keep many, many SREs families clothed and fed for a very, very, very long time. Is it bad? Yeah, it's bad, but I thought so. My new company, I'm going to talk as little as I can about the new company because I'm going to give a flagrant vendor pitch that Miko told me not to give, otherwise I would get kicked off stage. But I'm kind of going to do it a little differently because this is actually a part of the pitch where we want to pay SREs. I was really bummed to see so many people walking in the door with actual company names on their name tags because frankly, we're actually looking for people who are between jobs. It's a tough economic time out there. And if we can help out a little bit, I think that's a great thing. And if we can build a business by helping people who are between roles or helping people who need a little side hustle, I think this is an even better thing. If you want the vendor pitch side of it, believe me, I will happily give that. That is my job. I do a lot. I will give that over in the booth. But this talk, I'm going to try to describe what RunWhen does and as quickly as I possibly can, because the whole gist of this talk is we're recruiting authors to our author program. And that will make so much more sense at slide 8. So please bear with me. We've, the word observability has shown up a lot. The word Runbooks has shown up a fair amount. Everybody, I'm not going to have to define those. Every enterprise that I've ever worked in or with or for or near, reliability was all right, how much observability do we have? And then once we run out of experts who are willing to be on call at 2 a.m., how many runbooks can we write so that we can stick it to somebody else? And that works pretty well. But at a certain hyperscaler, actually most hyperscaler, the system works really differently. And I'm not going to go into which hyperscaler or why, but whatever. It's all about automation, and I want to double click a little bit more because that's a really easy thing to say and it's really hard to do. And we started RunWhen to make that much easier to do. So here's kind of the gist. It's a massive, massive shared library of what I would call templated steps. And when a new team is spinning up new services, you inherit all of these templates. So you actually inherit thousands and thousands and thousands of automated steps before you even write a single line of code. And that works pretty well. And then there's this really fascinating graph of, okay, from each step, okay, so how do you get to the next step? And that part, I think, is really, really interesting and takes a lot of configuration. And that part wasn't totally replicable in a world outside of hyperscalers. But AI does that part really well. And that, for me, was kind of what got me going, what made this business really work. Specifically, what I mean is AI is today, there's just not enough context there to try to write troubleshooting steps. Think of this as a step in a run book, not even an entire run book, just a single step. There's just not enough context. I don't think it's a limitation of the LLMs. We just can't get enough context into the system for them to write really good troubleshooting steps. But if the troubleshooting step has been written by somebody, hey, I've been troubleshooting Kafka for 2 years. When you see this, do that. Hey, I've been troubleshooting Postgres for 5 years. When you see this, do that. When I write a head log, I'll snarl it up this way. Here's what you do. Hey, you can reboot the thing safely, or no, you really can't. Just delete the log. Or run, hair on fire. This is things that humans assisted by AI are really good at, but AI alone can't really write the steps. is what we became convinced of after trying really, really, really hard. AI is like insanely good. Like not a little bit good, but we found LLMs and LLMs data structures that LLMs can easily create, one of that, are insanely good at taking the output of any one step and effectively doing a search. Here's one step. I'm going to search across like 10,000 potential next steps to try to find the right 5 next steps that I should take. And then from those, I'm going to find another 5, and from those, I'm going to find another 5. Now we can effectively stitch together these steps. Say you have a couple thousand steps that all came in from templates. We can dynamically put together millions of different runbooks. And this I thought was very interesting. Now we need to write all these templated steps. And this is where the authors program, I said slide 8, like I think I'm kind of there-ish. But we need to start writing all of these steps. Our company's goal is to build the industry's largest library of troubleshooting steps. We're starting with the Kubernetes ecosystem. That's where I have the most friends. The gist is to write troubleshooting steps for infrastructure on the major clouds that use underneath Kubernetes, the Kubernetes primitives themselves, the top 100 Helm charts are run on top of Kubernetes. At that point, by the way, we've got like 72% of the worldwide workloads on Kubernetes, so like we're doing pretty well there. And then if you look at that, start on the top languages and the top programming frameworks that are used on top. And I'll show you kind of current state of the library in a second. But the mission is to build this massive, massive, massive scale library. I have this kind of love-hate relationship with open source. I think open source has done incredibly. I think open source can move our community forward in a lot of different ways. I also think that there's a lot of commercial open source where a lot of people contribute and a small number of people make all the money, and it's incredibly opaque about how exactly the system is working. It's my own personal soapbox. So when we started this, we kind of had this idea, why don't we make it more like a marketplace rather than let's just hope that people contribute. When people contribute, let's pay. And especially if we have really, really strong people who are in between jobs, who have incredible experience troubleshooting something and want to harness that experience in a way where they can make royalties over long term. Whenever our AI digital assistants that you saw on the last slide say, all right, from one step, I'm going to go to the next, let's pay the author of a step a royalty. It seems only fair. They're the ones that wrote it. We now even started paying bounties. So when we have one of our big enterprise customers say, hey, I really want troubleshooting scripts for GitLab 3.9. We got a bunch for 3.8, and they made a couple of structural changes, so we need some updates. We now have enough of a pool of people that we can say, for a few $1,000s, somebody will update a whole series of scripts for 3.9. We have somebody who's ran 3.9, probably in production somewhere in the community. So our authors work for bounties and for royalties. And that has become our business model. We have, I won't go into the 4 level, that's kind of yes, but we think of, look, anybody can contribute, but a smaller number of authors are what we call accredited. So authors that we pay royalties and bounties, we call them accredited. Because we know they're not putting malware into their scripts. It's like a very real problem for a business like ours. Right now, I would say it's a little bit more like an art gallery model. Like the people who are accredited are, for the most part, friends, people whose code we review, people who we trust, people where we actually provide all the test infrastructure. It's kind of necessary for us to make sure that our early clients have really, really great experience. Over time, I think it'll become a little bit more of an app store model. But I do want it to always be curated because I want to make sure that the scripts that are getting contributed, where people get royalties and where people get bounties, are extraordinarily high quality. And I think that we can do that. Like as a community, I think that we have enough experts who are willing to work with us closely enough that we can build an awesome library. Like a really, really great library that's an amazing asset for anybody, whether they use our commercial platform or whether they use our library outside. Let me just pause there for one. Are there any questions about the author program? Because now I'm going to go into kind of the nitty gritty about building one of these steps. And then I'm happy to show demos of the whole thing working over in the other side at the booth. But let me just stop here for 1 second for questions, and then I'll go on. So let me just take a quick pause. And if nobody has a question, I'm going to start calling on you. It's going to be very uncomfortable.
I guess the part I'm missing is what is the framework that consumes this, these set of steps?
trying to figure out a short way to answer that without going into like vendor pitch mode. Think of it like a hybrid SaaS, like a runner within our customers, where they say, hey, okay, yes, I want to allow these 20 authors. That means that I have these 5,000 scripts on my side. And then we run a control plane that says run script 137. Okay, if you saw X, Y, and Z, then run script 248, run script 186, run script 782. Probably easier, frankly, to show a demo.
So, what is the width of all of these troubleshooting steps? Because one of the most common problems I have faced is like we have 600 plus open source libraries in our platform, and at any given time, Veracodes are like, this is vulnerable. You got to upgrade. You got to now there are breaking changes in those libraries. Are you covering that use case? That was my question.
So I think, to give you a sense, 25 people working not full time, but running about 3/4 time. I think that we can easily cover the top 100 Helm charts. I think to get to the top, give or take 600, I only think it actually takes about another 15 people, because they get much easier after you go through the top 100. We're not that far away from that right now. We have 4 people who are actively contributing. Then we have another 36 that are waiting for the next release of our author tools. So we're pretty close to the number of people that I think in, call it sub 2 quarters, can deliver coverage over a large number. There's also thanks to Bounded, hey, we need coverage over across these 3 open source packages. We can actually just turn around and say, hey, look, will somebody pick this up? And we generally go to our most trusted authors to say, hey, can you pick this up? Can you pick this up? Do you have experience? Have you run this in prod? Can you pick this up? And there's one more question.
I don't know if this is really on topic, but how do you guard against security or spam? What if somebody wrote a whole bunch of rules that just said, dump your database and just send it all to me? How would you guard against that?
In this business model, this is an issue. So this is why we have the sense of accredited authors. And I think most of our enterprise customers will run either troubleshooting steps that their internal engineers wrote, or will run scripts from our authors, run scripts from our accredited authors. And the accredited group is, we review code. Since we provide all the test infrastructure for everybody in our accredited group, and we require that people run regression tests, we get to see not only the code, but we get to see all the runtime characteristics of the thing. And we're even signing commercial agreements around exactly that. So we're really on the hook.
Last tiny question.
There was just somebody back
sorry.
there.
Hi, are you leveraging sort of internal ecosystem? In other words, say I'm writing test scripts and I want, a log file parser component. Why should I reinvent that if someone else is a total kick-ass one within the group?
So the structure, give me 3 slides, but the structure of our language, you can provide either troubleshooting steps, you can provide troubleshooting steps and also what we call robot keywords, which are effectively, think of them like macros that any other author can use as well. So that creates a lot of consistency to say hey, well, the most popular keyword is make this REST call and then dump the results to our postmortem report. And that's a single keyword. So we do find people say, hey, let me publish a bunch of keywords along with my troubleshooting steps that a lot of people can use. So we did a bunch of keywords, things like wrapping up the G-Cloud CLI, wrapping up the AWS CLI. An awful lot of that stuff is kind of wrapped cleanly so that you can import it very directly and get moving fast. And we really appreciate it when any of our authors, frankly, publish keywords along with their troubleshooting steps. That's just we can't find any way to actually compensate people for publishing their keywords. We can compensate people for the troubleshooting steps, but we just don't quite have the good mechanism. So people publishing keywords that other authors can use is just goodwill to the community. And the best that we can do is say thank you, and we can say a lot of thank you. Hopefully that's good enough.
Is the library, I assume it's open source, and then who's reviewing PRs?
So the way it works is every author submits their own repositories, and the library itself is actually a large collection of different repositories. So we don't review authors' PRs. They bring a full repo to us, and sometimes it's an individual, sometimes it's an organization that has their own sort of PR review process. The thing that we require is when somebody brings a repository, we actually build the whole repository. So the entire repository enters our build pipeline. It's a good question. I think I said all of it. Did I say all of it? I think I said all of this. Yeah, I think I said it. Yeah. Okay. Wait. Yeah, I'll say that part later. So when one of these assistants runs, the gist is not to like run a few steps. The gist is to run 100 steps. Because while we're recreating what human behavior would look like, two things. Like when we can run lots and lots of these in parallel, we really add a lot of value to like humans who would say like, wow, I have to hunt and peck across a very large infrastructure to try to figure out why my front-end developer is getting HTTP 500s. But I think more to the point, we initially started with systems that would try to go step by step by step in like one step at a time, very linear fashion. And we found that like the AI accuracy was good, but if they got like a little bit off at step 90% right at step 3 is like 50% right at step 10 is like 20% right at step 20. So when you can actually run these things and try to run, hey, let's do a lot of branching. Say, all right, given what we just saw, let's run 5 steps in parallel as long as they're read-only steps. We can actually get by without perfect AI accuracy. It's a little bit brute force-ish. It means that instead of looking massively intelligent, our digital assistants look a little bit more like a Roomba. They kind of just bounce around the room, but they do clean up the floor. And that's good enough. In fact, that actually works out really, really, really well. We find not only can they find, like we're pretty good now, given the coverage even the library already has, because we obviously use our own product, like we root cause most of the problems that our product has in our own beta environments, from beta. And even in the cases where we don't have good library coverage, so something's already escaped and we're like, oh, we really need that in the library, we can at least say, look, here are the 30 areas where the problem is not. And that we probably got there about 8 weeks ago internally, where we started saying like, hey, wow, this thing now can say, even when we have a hole in the library, we know which holes to patch, we know which holes to fill, we know which holes to fill. It was actually so useful in just running lots and lots of things that it just saves us a ton of time. When the assistants run a bunch of steps, the goal for us was to provide one single next step, whether that's an automated step or a non-automated step, to somebody who is on call, with the idea that that person on call may not be an expert in every single part of their entire tech stack. Much to your point, like how can a human know like all like 200 open source packages? So our goal was like one single next step for the non-expert. For an expert, an entire post-mortem report that's like pages and pages long with the output from every single script that ran. For managers, which we need, like, I don't think that anybody's introducing a tool unless it has something really good for executives. It's just the current economic environment that we're in. A whole bunch of analytics about, hey, here's where we had automation escapes. Here's how you can prioritize an automation program. Here's where the automation played a role when you had SLO and error budget drops, et cetera, et cetera, et cetera. But most importantly, for the purpose of this, we pay via the GitHub Authors program. Thank goodness that thing exists. I mean, without that, like that would be a huge amount of technical infrastructure that our business would have to write. And I don't know if anybody here works at GitHub or did, but like if you did and you were part of this program, just thank you. You did something great. We really appreciate it. Registry.runwen.com. I'll actually. At the risk of like showing my personal email here. So here's the registry. Here's where it stands today. These are the public repositories. There are another bunch that the author, for good reasons, mostly, the author hasn't made their stuff public yet. They still kind of feel a little sheepish. But this is kind of what the public repository looks like at this stage. You can see it's very, very, very heavy Kubernetes, but it's not all Kubernetes, not at all. Anything that you can express in a Python or Bash script, and assuming this model gets popular enough, then we'll release versions for Go, for Go and for Java. But I hope you kind of see like there's interesting coverage. So the registry is kind of talking with us is usually the first stop. Like, look, this isn't a 1,000-person community at this point. This is a small number of people getting this off the ground. Talking with us is the first step because we can point people really quickly to like here holes. If somebody will please write troubleshooting scripts for Istio, I'm just saying, like, that's going to be a high royalty collection. So how do the scripts work? I mean, the first step is that you use our SDK to import environment variables and secret. We'll go through like the syntax. I don't know if anybody's familiar with Robot Framework, but it lets you mix and match different languages underneath. We can go into that in a minute. But step one, you import environment variables and secrets. I didn't show that in the source code here. Step two, for pretty much all of these, is you collect information. So that's you're running CLI commands, you're running REST calls, you're running simple gRPC calls, you're running SQL queries. You have to do a big information collection step. This is, I would say, like 80% of our code bundle, maybe even 90% of our troubleshooting steps follow this pattern. Step 2 is that you dump the useful output to a report for some expert that's going to have to do postmortem work. And since generally most of the people writing these troubleshooting steps have been the person doing the postmortem work, they kind of know, like, all right, here's really what like I would want to see. And then step 4, we call them issues. You raise issues to say, hey, given what I saw, I think that here's an issue that needs AI review. Given what I saw, AI or human, hey, here's an issue, here's an issue, here's an issue, here's an issue. It says that something's unhealthy. I'm watching the clock. I'm almost there. You write a set of what we call generation rules. When our scanners scan Kubernetes clusters, AWS accounts, GCP accounts, Azure accounts, generation rules say, like, if you see this, then put in my troubleshooting steps. If you see Redis, hey, I have 20 great troubleshooting steps for Redis. It's kind of a way of like advertising your scripts for our internal indexers. That means that our indexers can put yours in by default. And a user kind of deselects rather than has to install them themselves. You work with our team to get integrated into our CI/CD pipelines. This is where like the art gallery versus farmers market versus like app store thing comes in. Because we want to know all of our authors at this stage in the game. That's important. And then you set up your repository for the GitHub sponsors program. Is where everybody starts. We have a template repository in GitHub. It has a bunch of our developer tools in there. It has like the early parts of the CI/CD pipeline to package everything up so they're all ready for our system. But the step 1 is always cloning the code collection template for everybody. And it's got a bunch of like working troubleshooting steps in there already that you can just start with and start modifying as you see fit. Ooh, sorry. I would say these author tools are in beta. And then we got something that's kind of nifty. I don't know if anybody else is tracking like the work around Devon and very specifically Open Devon and some of like the LangChain. We probably, this is very like 10 people in this room probably working for these companies. Yeah. We're working on something kind of similar that's built off of the same frameworks as Open Devon and some of the LangChain frameworks, where you just sort of roughly describe like, hey, here's the troubleshooting situation that I have, and a little bit about your environment, and then watch it start coming up with, okay, well, here are different steps that we think you should take, and then ultimately render those all the way out to code. Our goal was to make it pretty interactive. So you're like, oh, no, that step looks wrong. Oh, no, that step looks right. Oh, no, that's let's do a few more iterations there. I can show a couple demos, but I think I would call this labs. This isn't even alpha yet, but as this gets ready, then I think suddenly it makes it really easy for somebody who's I've been troubleshooting Postgres in production for 2 years, like get from that person's head out to really good, high quality troubleshooting automation without having to worry about all of just without getting lost in like the syntax of actually the programming language underneath. This is here so that when we share the slides, like the technical docs are up. Any feedback and all feedback on the docs are welcome. And I want to say a huge thank you to everybody for sitting through a flagrant vendor pitch about our author program, and it's an honor to be here. Thank you very much.
Do we have any questions for Kyle? Oh dear, all the way down there. So it looks like you have a lot of like code, and you have a lot of like data. Like, have you tried using like generative AI to get benefit? Like maybe I don't know. Have you tried?
So, for which part? So we use generative AI very heavily in the search.
Yeah.
All right, let's take the output of one step and look to the next.
Okay, one. And anything else?
So that we use it very heavily. And then since it's kind of like the perfect tee up, here's let's call it the alpha level code bundle builder to actually build troubleshooting scripts. This is like really, really, really risky. And like if you could turn off the recording, we're just gonna like let that run for a little while. And maybe it'll do something, which would be really wonderful. I think one thing that we found is it's not that the LLM isn't accurate enough. It's just that it's really hard to give it enough context to generate really, really high troubleshooting steps by itself, and certainly cannot generate them on the fly. Like we tried that, and man, shit went off the rails. So like not the position that I want to be in. So we do think that there's going to be a lot of human in the loop in the course of building up these troubleshooting steps. I'm very interested in AI tools to make that easier and easier and faster. I hope you're kind of getting the gist of like where this thing sits at the moment. These can all render out to code, but even then, I would say like pretty good, like 80 to 90% right. But you still want a human who knows what they're doing, even if not like editing the code itself, because the code itself is generated, but saying like, oh wow, no, that thing, let's do a redo. I do think that we're going to be there for a while because this isn't an LLM problem. This is giving an LLM enough context to be successful problem. It's like saying, let's give a massively difficult distributed systems problem. That's not only a computer science problem, but that involves a whole bunch of internal data structures and a whole bunch of flaky internal databases to like our newest intern on week 1. It's not setting somebody up for success, and it's not setting LLMs up for success unless you give them a lot more context.
How do you make sure you're not sending secrets along to like your LLMs, for example, or?
So we have a very specific SDK for secrets handling, both to import secrets up front, and it actually it logs all use of secrets back and forth. When we have people test their infrastructure against ours, we can actually tell when their code is actually reading secrets. So we put a lot of work actually into that part.
How do you guarantee that you haven't read secrets from, I don't know, when you're doing some Kubernetes debugging or something?
So the actual tasks themselves, since they require credentials, right? So they require some amount of secrets. The tasks themselves are actually running in the customer's infrastructure. So they are importing secrets. They're in the customer's infrastructure. They're actually importing secrets. They're running things. And then they don't actually send the task output itself all the way back to us. The task output is actually also stored. They send metadata, that's structured metadata about the task output back to RunWhen, and we use that for our algorithms to say what step to run next. Because there's a reasonable chance that the task output has a credit card number in it, has a social security card number, all stuff that we do not want on our back end. But the metadata itself about the task is pretty safe. Like it's hard for me to figure out how somebody would get private data into the metadata.
Do you also have, like performance related SR issues? Like my system is still up, but downgraded performance, right?
Yeah.
So
we have a few that we wrote for our own use that are public. So I would say like our library, we don't have tons yet, but we certainly have the existence proof that it can be done because we needed them, so we wrote them. And I'm kind of eager for like a really, really ultra performance oriented automation person to come into our community and say like, all right, I'm going to do it. We really need somebody there on Kafka, like in 2 weeks.
Is there an assumption that the customers that may be running these fragments of code in their environment, that they have certain languages available, like Python 3.7 as opposed to 3.10, like the subtleties like that? Are those kind of understood?
For the tasks themselves, we're actually running them in containers that are packaged by our CI/CD pipeline. So for the task to execute, no, it's actually running in a hermetically sealed container. It takes absolutely zero input other than the credentials from the outside world. And zero software dependency. Anyways, long soapbox there. The author who wrote the task may make some assumptions about the end user's environment. And so I think part of our goal is to have authors in the program who have like very open dialogue, like our end users can file issues onto their repositories to say, hey, your task made X and Y assumption. Can you modify it so that it actually works for my environment where the assumptions are different? Our goal is to not be in the middle of those, but in fact, like to facilitate a really, really, really open dialogue back and forth. And we certainly found that, like the GitLab example is actually very real. Like we were running GitLab 3.8, and we needed, there were breaking changes to some of our troubleshooting scripts when there was a move to GitLab 3.9. We didn't upgrade, but one of our customers did.
All right, last quick question about the testing harness, I guess. No pun intended there. Is it kind of like chaos engineering? You get a package that, I don't know, starts Redis, induces a failure, and then you can verify that your troubleshooting steps actually work as intended? Is that how it works? Or
the chaos's name is John. Right now I don't know that we have that. That's not totally automated. Like right now we actually work with our authors to say, hey, let us set up a testing environment for you.
Right.
Because if you think about it, the testing environments, let's go back to the GitLab example. Somebody actually needs a full up and running version of Enterprise GitLab in order to test their stuff. Our author shouldn't have to pay for that. I mean, like, what a ripoff. Like, we'd say, like, hey, we'll pay a royalty, but by the way, you have to actually pay to run regression tests for GitLab 24/7. Like, that's great. So our view is like, we'll run all that infrastructure. And at least to date, we basically work with authors in a big sandbox environment to say, all right, what infrastructure do you need? Let us set it up for you. If it needs to be healthy, we'll set it up healthy. If it needs to be broken, tell us how to break it. If it needs to run scripts on your side in order to break it, let us help get all of those up and running as part of the test exercise.